I put together a package here. It's basically a PowerPoint presentation for students everywhere who are about to take their undergraduate statistics final exam. After teaching statistics at the college level for more than 20 years, I'm pretty good at predicting what you might see on your final exam. So I put together a package. This is not meant to go through and tell you all of the formulas. It's not meant to go through and show you how to do all of those things. But I do have a lot of help available in the StatCave. The address is there on the first chart, and it's a difficult address to remember, but I kind of like it that way. It makes me a little harder to find, but love to have you come visit me, and hopefully you will do well on your final exam. Let's take a look at some of these things. Population versus sample. Remember that when we talk population, we're talking all, we're talking everybody, we're talking everything being sampled, considered, everybody, all right? A sample is simply a subset of the population you're studying. Remember that parameters come from populations and statistics come from samples. P goes with P, S goes with S. Also remember, when we take a census, we are getting data from the whole population. And your population doesn't have to be an incredibly large number. Let's say you're running a small company of 50 people. Rather than sampling, you could easily do a census. So sometimes we sample, and why do we sample? Well, usually it's because of cost, time, the overall feasibility of getting data from everyone is often just not possible. Levels of measurement. I like to tell my students, remember the acronym NOIR, N-O-I-R. There are 4 levels of measurement. Nominal. The nominal level of measurement is just things like colors and descriptions and things that you cannot logically order. And then you've got the ordinal level of measurement, which can be logically ordered. You know, say I was asked to rate the new song on a scale of 1 to 5. That would be ordinal. Good, better, best would be ordinal. The top 100 is ordinal in terms of the Billboard top 100. The college football top 20 would be ordinal. Now, interval are numbers with meaning that can be, added and subtracted, but there's no real zero. Well, you got to be careful when you say added and subtracted, but there's no real zero. The best example for the interval level of measurement is temperatures in Fahrenheit, because they can go below zero, -3 degrees Fahrenheit. Then there's ratio. Ratio has a true zero. Zero is the bottom. In other words, how many cousins do you have? You cannot have -3. How many cars are in the driveway? From 0 to whatever. How many sandwiches did you eat today? Well, you couldn't have eaten -7 sandwiches. Types of data collection and sampling. You always need to know this. First of all, there's convenient sampling, which is by far the least effective type of sampling. You just go around the house and say, well, who's your favorite candidate running for mayor? Or you just go down to the local pub and you ask them who their favorite football team is. Well, chances are, if you ask people in one certain geographic area a question like that, they're all going to be for the same team. So convenient sampling is just sampling due to convenience. You are not getting a true picture of the population. Random sampling, simple random sampling, is like like putting everybody's name in a hat and drawing it out. Putting the kid's name in a hat and get to see who sits by the teacher, or something like that. Simple random sampling, random sampling. Systematic sampling is sampling every nth person or thing, like doing a quality check on every 20th circuit board that comes off a line, or like asking every 10th student in line what their major is. Then we have cluster and stratified sampling. With cluster and stratified sampling, they're similar because you first divide into groups. With cluster sampling, you divide your population into a group and randomly pick one or more of those groups and sample everyone or everything in that group. In other words, let's say there's 20 statistics classes and you randomly pick one of them and you ask everybody in that class, or sample, or survey. Maybe you've got 20 classes and you select 2 and ask everybody in that class. Still cluster sampling. With stratified sampling, you divide your population into groups and then pick a certain number or percentage from each group. Going back to the class example, I've got 20 statistics classes and I go back and I sample 2 students from each class. That would be stratified sampling. Stem and leaf plots. You will almost always have stem and leaf plots on a final exam in undergraduate statistics. Well, you might have. I think there's a strong chance that students should know this. I think it's a cool thing. As far as doing them, they're real easy in terms of setting your stems and leaves up, and you do that logically. What makes the most sense to be the stems? Like in this case, I've got data 11, 12, 13, 18. So my stems would be in terms of 10. So in the tens, I've got 11, 12, 13, 18. Also notice with a stem and leaf plot, if I've got multiple values, I will have, not multiple values, but replicated values. I still list them both, like 21, 21. I list them both. Remember, you should be able to count your number of leaves, and that will equal your number of data points. Another thing, to describe the shape of a stem and leaf plot, just rotate it 90 degrees counterclockwise. Like on this one, you can rotate it and you say, wow, that's right skewed. Other types of graphs and plots. Chances are you've learned to create and interpret many types of plots and graphs, including pie charts, dot plots, bar graphs, histograms, frequency histograms, things like that. So I would always be ready for those. The shapes of distributions. I like to tell my students there's 3 basic shapes. You've got the normal or bell-shaped, symmetrical curve. It doesn't have to be perfect, and that's one thing that students sometimes get mixed up is, you rarely are going to have a perfect normal, but it can be almost normal. What you're looking for is a dramatic tail. Like, think of a cat under a sheet dragging its tail to the left. That's skewed left, or having a tail to the left. Or that cat dragging its tail to the right. It's skewed right because it has the tail on the right. And what causes skewness as far as where the mode, median, mean? What I like to say is that the mean hugs the tail. In other words, in a left skewed distribution, the mean hugs the tail or is closest to the tail. The mode holds up the tent, it's the tall pole. The median is there in between on a left tail distribution. With a right skewed or right tail distribution, the mean still hugs the tail out to the right, the median's in the middle, the mode is the tallest point and it's holding up the tent. Descriptive statistics. An undergraduate statistics exam, I can almost give you 100% probability, or a probability of 1, that you'll have descriptive statistics on a final exam in undergraduate statistics. You should know things like the range, the mean, the median, the mode, the variance, the standard deviation. And remember, when talking about the modes, you can also have no modes. You can have 1 mode, 2 modes, of course, you'd say that's bimodal. More than 2 modes is multimodal, but the mode is only the most frequently occurring data point. Always be ready with descriptive statistics to use the allowed technology in your course and have it ready and understand how to use it. That might be a calculator, it might be Excel, it might be statistical software packages like Minitab or something like that. Always have them ready and know how to use them. Another thing, I've seen these type questions on tests before. Understand how the variance and the standard deviation are related. In other words, if they say, the variance is 9, what is the standard deviation? Well, the square root of the variance is the standard deviation. So if they told me the variance was 9, the square root of 9 is 3, so the standard deviation would be 3. On the other hand, they could say the standard deviation is 5. What is the variance? Well, to get the variance from the standard deviation, you simply square it. 5 squared is 25. So if the standard deviation is 5, the variance is 25. Now, another thing that you should understand is how standard deviation works. The standard deviation is simply the spread of the data. I've got 3 distributions here. The red one, or the skinniest, has the smallest standard deviation. The blue one's kind of in the middle, but the green one looks like somebody took it on the left and right and pulled it, so it's got the largest standard deviation. The empirical rule, hopefully you have studied the empirical rule and know what it is. Sometimes the empirical rule is called the 68, 95, 99.7 rule. That's simply because the empirical rule states that if we've got a distribution that's normal, almost normal, we can assume that 68% of the values fall between plus or minus 1 standard deviation. 95% of the values should fall between plus or minus 2 standard deviations. And 99.7% of the values should fall between plus or minus 3 standard deviations. Now here's an example. Let's say we have a situation with a mean of 20 and a standard deviation of 4. Based on the empirical rule, 68% of the values would fall between 16 and 24. 95% of the values would fall between 12 and 28. All I'm doing on that one is saying 20, or the mean, minus 2 times the standard deviation, and the mean plus 2 times the standard deviation. 99.7% of the values would fall between 8 and 32, because that's the mean plus or minus 3 standard deviations. So always be ready for the empirical rule type questions. I've got a little Excel file called the Empirical Rule Calculator. I'll try to tag that on to this post over in the StatCave somewhere toward the bottom. I'm going to stop here and continue with a video. I like to keep them under 15 minutes each.